Hello everyone, welcome to Innovium Learning, your learning platform, and we are your mentors, coach, and I am your chemistry teacher. Uh, Already you all know about what is Innovium Learning, and this is the first ever EdTech platform launched from Odisha, and this is yet another class on that molality as well as for molarity, and today I am going to discuss some numerical problems based on that concept, whatever we have discussed in earlier classes. Okay, so let's start. I think in the last class, we have already discussed that relationship between molality and molarity. And in that relationship, what I have discussed that the relationship is like this. One, 1 by molality is equal to density of solution by molarity. This is molarity minus this is molar mass of solute in gram by 1000. Correct. So this is the expression. We have already proved this expression. We have derived this expression, and today we will discuss some questions based on this expression. Now you see, yes, in one more important expression we can also obtain from this expression if the molar mass of solute is given in kg instead of gram, if it is given in kg, and if the density of solution is given in kg per liter instead of gram per ml. Here this is in gram per ml. This is in gram per ml. So this is in density of solution, this is in gram per ml, and if it is in kg per liter and molar mass of solute is in kg, then the expression will be like this: density in kg per liter by this is molarity minus, and this is your molar mass of solute in gram. Instead of that, if it is given in kg, then the expression will be like this: this is molar mass of solute in kg. Correct. Now the question is, why only this factor comes, why not this 1000 comes? The reason is, you know that 1 gram is equal to 1 by 1000 kg, right? Now if we have x gram, if the molar mass is x gram, if the molar mass is x gram, then how much it is in kg? That is x by 1000 kg. Exactly. Here you see, if the molar mass is correct, if the molar mass is molar mass is certain value with gram unit, then how much it is in kg? Then that is equal to that mass in gram by 1000, that much kg. So here you see, here the molar mass in gram is equivalent to how much in kg? That is equal to that molar mass in gram by 1000, that much kg. So in place of this, directly we can put that molar mass of solute in kg. So this much molar mass of solute in gram, that is equivalent to how much in kg? This much molar mass of solute in kg unit. Correct. Now, so this is another expression for molality and molarity if the density is given in kg per liter and molar mass of solute is in kg. Now one more important thing, what is that? You see, here density of solution by molarity is given, mentioned here. That same expression is also I am using here, because you know that 1 gram per ml, 1 gram per ml is same as 1 kg per liter. That's why no change you will find with this part. No change you will find with this part. If the density of solution is given in kg per liter, correct, then you can also use this same expression here. So here density of solution is in gram per ml, and this is molarity. This is density of the solution in kg per liter by molarity. Correct. No change, because whatever density is given in the question in gram per ml, that much is also you will get for the density in kg per liter. Suppose the density of solution is 5 gram per ml, that is equal to 5 kg per liter. Why? You see 1 gram per ml is equal to 1 kg per liter. So 5 gram per ml is same as 5 kg per liter. How? You see 1 gram, if you convert this gram to kg, then how much it is in kg? 10 power minus 3, correct? And 1 ml is equal to how much in liter? That is 10 power minus 3 liter, correct? Now this is equal to what? This 1 gram per ml is equal to what? 10 power minus 3, 10 power minus 3 cancel. So this is coming 1 kg per liter. So 1 gram per ml is coming what? 1 kg per liter. So whatever density of solution is given in gram per ml, that same value will come in that kg per liter for the density, correct? Now that's why in this part no change you will find, correct? Now here in this part you will only find that change if that molar mass of solute is given in kg, then only you will consider this term instead of this 1000, because this much mass in gram by 1000 gives you the molar mass of solute in kg. Now directly we'll go to this question, correct? So you see, what is given in this question? So see, in this question it is given that molality of sulfuric acid solution is given 0.2. Calculate the total weight of the solution having 1000 gram of solvent. It is a very fundamental question based on that basic formula, basic definition of molality, correct? So what is that formula of molality? Molality is equal to number of moles of solute, correct? So that number of moles of solute, this is number of moles of solute present in 1 kg or 1000 gram of solvent, correct? So here it is 1000 by W solvent. This expression is valid when the solvent mass is given in gram unit, correct? Now you see, in this question it is given that the molality of a sulfuric acid solution is 0.2. If the molality is given 0.2, then molality is given 0.2. What is that unit of molality of what is that unit of molality? Molality unit is moles per kg. Moles per kg means here the given data is given data of molality is 0.2 moles per kg, means 1 kg of that solvent contains 0.2 moles of that solute, or you can say 1000 gram of the solvent contains 0.2 moles of the solute, correct? So here we can consider 1000 gram or 1 kg of solvent contains 0.2 moles of that sulfuric acid. Sulfuric acid is H2SO4, correct? Now you see, so here 0.2 moles of H2SO4. What is that mass of 0.2 moles of H2SO4? That mass of 0.2 moles of H2SO4 is what? Mass of 1 mole of H2SO4 is what? Mass of 1 mole of H2SO4. So you see, mass of 1 mole of H2SO4 is 98 gram, right? So here you see, mass of 1 mole of H2SO4 is 98 gram. So what is that mass of 0.2 moles? 2 moles of H2SO4. That is 98 multiplied with 0.2, this much gram. So it is coming what? I think it is coming 19.6 gram. Correct? So this is 19.6 gram. So this is the mass of 0.2 mole of H2SO4. Now this much mass of H2SO4 is present in what mass of that solvent? 1000 gram. Correct? So here in this question, what is given? Calculate the total weight of the solution. Means you will have to find out the total weight of the solution. Means mass of solute along with mass of solvent together you will have to calculate in what solution? In that solution where the solvent is present by what mass? 1000 gram mass. Solvent is present by 1000 gram mass. So here you see, so here we have exactly considered what mass of solvent? 1000 gram or 1 kg of solvent, because molality is given 0.2 moles per kg. So 1000 gram of solvent is having 0.2 moles of H2SO4, and this 0.2 moles of H2SO4 is nothing but the solute present in that solution, and this mass of this 0.2 moles of H2SO4 is 19.6 gram. Then what is that mass of solution? So mass of, or you can say total weight of the solution, total mass of solution containing what mass of solvent? Containing 1000 gram of solvent is equal to what? That is mass of solute, that mass of solute in that 1000 gram plus mass of solvent, which is nothing but 1000 gram. So this is 19.6 gram plus this is 1000 gram. So how much it is coming? 1019.6 gram. So this is the answer. So here you see the answer is option D. Got it? Now you see this question can be twisted in different form. Like instead of given 1000 gram of solvent, the data may be given 2000 gram or 1500 gram, or any mass of solvent may be given. Correct? Sometimes the data may be given changing that molality, or you will calculate the, instead of total weight of the solution, sometimes the mass of solution will be given. Correct? So instead of 1000 gram of solvent, suppose the question is given 1000 gram of solution. So in that 1000 gram of solution, find the mass of the solute. Molality of the solution is given. Correct? So here it is, let's say here it is given 0.2, and instead of 1000 gram of solvent, data is given 1000 gram of solution. So in 1000 gram of solution, what is that mass of solute? Correct? What is that mass of solute, and what is that mass of solvent? That you calculate. So this is your question, this is your homework. So all of you try that question and comment me in that chat box, or in the next class we'll discuss. So write down that question. Here you see the molality of the solution of sulfuric acid is given 0.2. Calculate the total weight of the solute having 1000 gram of having the mass of solution 1000 gram. That means here this 1000 gram of solvent we have taken, but instead of that, simply you consider the mass of solution is 1000 gram. In that, what is that mass of solute? What is the total weight of solute as well as solvent? Correct? So in the next class we'll discuss that. So let's go to that next question. So you see here the question is molality of pure liquid ethanol if its density is given 1.2 gram per ml. This is very easy. So you see this is also based on what? That direct formula or that basic definition. Correct? So what is the definition? Definition of molality, or that formula, basic formula of molality. That is you see that is number of moles of solute into 1000 by this is W solvent in gram per ml. Sorry, this is W solvent, only solvent in gram. Correct? W solvent in gram unit. Now here you see this can be yes, you see this can be expanded, number of moles of solute. Now tell me, if the mass of solute is given and molar mass of solute is known to us, then how can we find out that number of moles of solute? That is mass of solute by molar mass of solute. Given mass of solute by molar mass of solute gives you the number of moles of solute. So this is one of the formula to find out number of moles of solute if the mass of solute is given. Correct? Now multiplied with 1000 by W solvent in gram. Now, the point is here, in this case, suppose the question is asked, find the molality of pure liquid. Molality of pure liquid, not a solution. If the solution is asked, if the solution is given and for that solution molality is asked, then here we can use number of moles of solute into 1000 by W solvent in gram. Now the question is, instead of that, if the question is given molality of a pure liquid, here you see the question is based on that molality of pure liquid. So in this case, no solute is there. That liquid as ethanol will act as solvent as well as solute, means no additional solute is added in that liquid ethanol. So in that liquid ethanol, no additional solute is added. That ethanol can be interpreted here as solute as well as that can also be interpreted as solvent. Obviously that is solvent. So solute here we can consider that ethanol can also be interpreted here as solute. So in this case here, whenever you find this type of question which is a pure liquid, correct, for that case always you consider that solute and solvent, correct, that solute and solvent to be the same substance, to be of the same substance, correct. Now here you see given mass of solute, so in place of this we can consider mass of solute or mass of solvent. This is also mass of solvent. So here this is mass of that same solvent, because solvent here is interpreted as solute, by this is molar mass of that solvent, because solvent and solute here interpreted as same. So here you see this is W solvent in gram. This is also mass of solvent in gram. Now this term will be cancelled, because this is mass of solvent in gram, this is also mass of solvent in gram. Both are cancelled. Now what is left? This one. So this is 1000 by molar mass of solvent. So this is 1000 by molar mass of solvent. Now this is the expression to solve this question. So whenever you find a pure liquid is given, in that case solvent and solute both means the same, both means the same substance, and in that case the molality expression is reduced to this form, that is 1000 by molar mass of solvent. So now you apply this formula directly here to solve this question. Now just to make you confused, the density data is given. Here the density data which is given, that is of no use at all to solve this question, correct. Now what is that answer of this question? So you see density is given 1.2 gram per ml. This is of no use, only we'll use this formula. So what is that molality? So the molality is equal to what? 1000 by molar mass of solvent. So what is that molar mass of that ethanol? Ethanol molar mass is carbon 2 carbon. 2 carbon means 12 into 2, 24 plus 5, 29 plus 1, 30 plus oxygen mass is 16. So 46. So molality is 1000 by 46. I think if you solve this one, you will get the result 21.74. This much moles per kg. This is the unit. Unit of molality is moles per kg. So the answer is coming 21.74 moles per kg, or in short we can write down 21.74 small m. Small m stands for molality, correct. So I hope all of you got this answer, and this is the expression to find the molality of pure liquid, that is 1000 of that 1000 upon what? Molar mass of that pure liquid, correct. This is 1000 upon molar mass of that solvent, or you can consider molar mass of that pure liquid. Next question. Molarity and molality of pure acetic acid are respectively. So you see, here you see that molarity, for molarity what is that definition? Definition is number of moles of solute present in 1000 ml or 1 liter of solution, present in 1000 ml or 1 liter of solution. Now you see here number of moles of solute present in here 1000 ml, or you can say 1 liter of solution. Correct? Now the question is here, what is that role of density? What is that role of density? Correct? So that you can get from this expression which I am going to explain. So you see, so this is the number of moles of solute. If the volume of solution, is given, if the volume of solution is given in liter, so you see, if the volume of solution is given in liter, then this is the expression for volume of solution in liter. Then this is the expression for molarity. But if the volume of solution is given in ml, then the expression is like this. Volume of solution in liter in ml, sorry, this is in ml, by 1000. Correct? So this one. Sorry, this one is yes. So you see, now this, if the volume of solution is given in ml, then the expression will be like this, that is 1000 by V of volume of solution in ml. Correct? Because you know that 1 ml is equal to how much in liter? 1000 by V. Correct? 1 ml is equal to 1 by 1000 liter. So VML is equal to what? V by 1000 liter. Correct? So if the volume of solution is given in ml, then number of moles of solute by volume of solution, if the volume is in ml, that is V by 1000. So that V by 1000 becomes what? 1000 by V. That's why here I have mentioned number of moles of solute multiplied with what? 1000 by V solution in ml. So this is the expression for molarity. Now this N solute is what? This N solute is mass of solute by molar mass of solute. Given mass of solute by molar mass of solute multiplied with 1000 by V solution in ml. Now the point is, what is this? Tell me. This one, W solute by volume of solution. What does it represent? It represents density of solution. Correct? It represents what? Density of solution. So density of solution into 1000 by molar mass of solute. This is the expression for molarity. Whenever density data is given, in that case, how can you find out molarity? This is the expression. Now you put that data given here, density is given 1.5 gram per ml, then easily you can find out molarity. So molarity is equal to what? That is density of solution. What is the density of acetic acid solution? That is 1.5 into 1000 divided by, what is that molar mass of solute? Molar mass of acetic acid is 60. Carbon, 2 carbon, 24, 4 hydrogen, 3, 1, 4 hydrogen, 4, 24 plus 4, that is 28. Correct? Then 2 oxygen, 32. Correct? So adding all these masses, you will get that molar mass 60. Then if you simplify this, this is 1500 by 60, and I think it is coming 25. 0, 0 cancel, so this is coming 25. So the answer for molarity, so this is coming 25. So for molarity, what is that answer? Answer is 25. Now, what is that molality? What is that molality? Now the point is here, in this case, for molality, you know that if it is given a pure liquid, then molality can be directly calculated. Just now I derived in the previous question. What is that? 1000 by that molar mass of that pure liquid. Correct? Now this is 1000. What is that molar mass of that pure liquid? Acetic acid, that is 60. So it is coming 100 by 6. So this is 16.67. So here this is the molality. So answer is B. So with this we finished all the questions of today's class. Now you see one more concept I would like to discuss based on that comparison of molarity and molality. In the previous class actually I have discussed that for expression for that molarity and molality, how to relate that molarity with molality, and based on that expression we'll discuss one comparison between molarity and molality. Correct. Let's discuss that. In fact, in that comparison, you'll get to know under which condition in a dilute solution molarity will become greater than molality, molarity will become less than molality, and will become equal to molality. In fact, in many questions, while solving many questions in solution chapter, for dilute solution, for dilute aqueous solution, we generally consider that molality is same as molarity. Why? So what is that concept behind that assumption? So you see, actually that expression between molar, for that expression for the relationship between molality and molarity, that is this one, density of solution by molarity minus, that is molar mass of solute by 1000. So if you multiply molarity, if you multiply this expression with molarity, then you will get molarity by molality. This is coming density of solution minus this is molarity multiplied with molar mass of solute by 1000. Now you see, if the solution, so here we will discuss three cases. Case 1, you see, and here you see, if the solution is very dilute, if the solution is very dilute, means you can take the molarity as what, 10 power minus 2, that means 10 power minus 2 molar solution, or you can say 0.002 molar, 0.004 molar, or you can say 10 power minus 4 molar solution, 10 power minus 5 molar solution. Means all these solutions are very dilute solutions. Suppose you consider molarity is 10 power minus 5 molar. Molarity is what? 10 power minus 5 molar. Means in this case, what we can say? Means the solution is 10 power minus 5 molar solution. 5 molar solution. Means this solution is a very dilute solution. If the solution is very dilute solution, then you put that value here, 10 power minus 5 into molar mass of solute by 1000. You see, this quantity will become a very small quantity. This quantity will become a very small quantity. 10 power minus 5, here it is 1000. So this becomes what? 10 power minus 8. So this quantity will become very small quantity, and this quantity can be ignored with respect to this density of solution. Means wherever you find molarity of the solution is given very small, like 10 power minus 2, minus 3, minus 4, minus 5, any smaller value of molarity, then in that case you can ignore this term with respect to this. Why? Because density of solution, if you are considering aqueous solution, then density of solution will be definitely greater than 1 at room temperature. At room temperature, you know the density of water is 1 gram per ml. If you consider aqueous solution at room temperature, definitely the density will become greater than 1. So this value is greater than 1, and this quantity is very small. This quantity comes in 10 power minus 3, minus 4, minus 5. So this quantity can be easily ignored. In that case, for very dilute solution, we can consider m by m is nearly equal to density of solution. Correct? That implies, so for very dilute aqueous solution, we can consider m by m nearly equal to what? Density of solution. So if m by m is nearly equal to density of solution, then for that case we can have three different a comparison between molarity and molality. So you see, case 1, m by m. Here you see, this is coming for very dilute solution. You see, for very dilute solution, if you see that m by m is coming, density of solution, this term is ignored or neglected with respect to this. Now you know that for very dilute solution, that for if you are considering that aqueous solution, if the solution is aqueous solution and it is very dilute, then you know that density of solution for very dilute aqueous solution, density of solution is nearly equal to density of solvent, that is nothing but H2O, because solvent is nothing but H2O or water, because this is aqueous solution, and density of water is nothing but, that is equal to what? That is equal to 1 gram per ml. So you see, and why the density of solution is equal to density of solvent in case of very dilute solution? Very easy. So density of solution is nothing but what? That is mass of solution by volume of solution. Correct? So this is mass of solution by volume of solution. And if the solution is very dilute, then in that solution, solute mass is negligible. Solute is present in very negligible amount, or you can say solute mass is negligible. So whatever mass is there in the solution, that is mainly due to what? Mass of solvent. And whatever volume of solution is there, that is also due to that volume of solvent, because the solvent amount is solute amount is negligible. So solute mass is also negligible, solute volume is also negligible. Therefore mass of solution is mass of solvent, and this is also volume of solvent. Now this is coming what? Density of solvent. That is what I have taken here. That is for this case, water is the solvent. So density of that water or solvent is coming 1 gram per ml. So for very dilute aqueous solution, you can consider density of solution is equal to density of water, which is equal to 1 gram per ml. Now if I will put that density here, density of solvent, that is water, then what is coming? This is equal to 1. Then this is equal to 1 means molarity becomes, so you see, you know that m by m becomes 1 means what? Molarity becomes equal to molality. So that is why in many questions while solving many questions in solution chapter, we assume molarity becomes equal to molality if the aqueous solution is given, that too very dilute. Now the case 2, case 3, that is your homework, that under which condition molarity will become greater than molality and molarity will become less than molality. Correct? That also you can derive from this expression. So I hope all of you got the concept in today's lecture, and will very soon will come up with a P block series. That is a very good news for the JEE Main Session 2 appearing students and Neet appearing students. That P block series will be uploaded very soon, and the test series is already launched for that JEE Main Session 2 as well as for Neet, and our app is already ready, and anytime today it will go live. And all those who are new to this platform, do subscribe our channel, and description detail is given in the chat. Description detail is given, and thank you all